Hello, this is Dr. Lori. Welcome back to our discussion on statistical inference and hypothesis testing, kind of the big picture. So we've looked already at the idea that statistical inference or making a conclusion is a part of the research process and how that fits into the big picture. We've also talked about making a conclusion and what if you make the wrong conclusion. So now let's finish up by thinking through the actual steps that we take when we are testing a hypothesis. So what I'd like to do is I would like to think about the question that we asked before. We know the average height of 12-year-olds in California is 150 centimeters. Now we want to know for perhaps a specific location or a group of individuals, how does their average height compare to that particular preset norm? And so the hypothesis test that we would go through has 5 basic steps, and different places will list these a little bit differently, but the content is essentially the same. We start out by saying what we are interested in studying. And we say that in a specific way, and we call that a null and an alternate hypothesis. So here's our null, and here's our alternative hypothesis. Remember that we're always testing the null hypothesis. It's the one that says there's no relationship, all the groups are equal, there's nothing interesting going on here, we can't find anything that makes us think that there's any kind of relationship at all. And the alternative hypothesis is usually our research hypothesis. It's why we thought about studying this particular phenomenon in the first place. We think that there is a relationship between height and living in a certain location, or we think that there is a relationship between two variables, say gender and height, or height and age, those kinds of things. So what are we interested in studying? The second thing is we need to decide our maximum chance of rejecting the null but being wrong. And so before we even run the statistical test, we make this decision beforehand. We call that a priori. We set our alpha. Alpha is also the Greek letter alpha. Is defined as the maximum chance of rejecting the null but being wrong. So in other words, we set the highest price that we're willing to pay in order to be able to study this relationship. By default, the alpha typically is set at 0.05, which is equivalent of saying 5%. Now, this is a historic level. It's just another way of thinking about it is 1 in 20 of the times, then we would reject the null, but we would be wrong. And historically, somebody 100 years ago or however long decided that 1 in 20 was an acceptable level of making this mistake, of being wrong, of making a type 1 error. So we decide our alpha before we even do our test, and then we have that already decided. Now it's possible to set alpha at a different level, and we'll talk about that later. This is just kind of like a very generally accepted alpha. We could set alpha at a different number. It's not automatically 0.05, but it usually is. If you were to set it at a different level, you would probably want to explain why. So alpha at 0.05 is pretty standard. The third step is to test the significance. And when we say test significance, really what we mean is we want to crunch the numbers. We want to go into our computer program, be it SPSS or SAS or R or Minitab or whatever kind of program, and we're going to tell the computer to calculate something called the critical ratio. This is like a t-value or a z-value. It could be all different kinds of things that we're calculating. And we'll learn more about the critical ratio later. But then that critical ratio is converted into this chance. We convert the critical ratio into something called a p-value. And that p-value is also synonymous with something called sig, or significance. In the SPSS output, you'll actually see this right here. You'll see this as a column header, and so that's what you're looking for. That is your p-value. That is your chance of rejecting the null but being wrong. And then what we do as a fourth step is we compare our p-value, the one that we got when we when we ran the statistical test in the software, we compare that p-value to the alpha we decided up here in step 2. So in other words, we compare number 3 to number 2. And so we're comparing the actual calculated chance of being wrong when we reject the null to the preset maximum that we decided ahead of time. So we're comparing number 3, our final results, to number 2, the set alpha that we decided before we did the test. And then based on that comparison, our final step is to either decide to reject the null or to fail to reject the null. In other words, we're concluding, we're inferring. Remember, inference, I'm going to go back up to the definition. Inference is a conclusion. Let me draw a conclusion reached based on the basis of evidence and reasoning. And so here we are, we're coming to a conclusion and we're basing it on the evidence that we've drawn. We've run all of these statistical tests, and then we're thinking through the process of what do those mean. And so we're going to, this final step is to infer whether there is a relationship between the two variables. Step 1 is there a relationship between these two variables? Step 5 answers that question, answers that hypothesis. And the way it does that is that if the p-value, remember, step 4 is to do this comparison. If the p-value is too high, if it is a large number, if it's bigger than this preset value, then we fail to reject the null. If the p-value is small, it's less than alpha, then we reject the null hypothesis. In other words, we say our actual chance was not too high of being wrong. It's also important to state that conclusion that we have, not just reject the null or fail to reject the null. It's important to state that conclusion in what I call common language. So in other words, if you remember over here, we said we can say the null hypothesis a variety of different ways. Here we have 3 different ways of saying the null hypothesis. So if we conclude that we're going to fail to reject the null here, then we could say reject the null and the average height of 12-year-olds in Coachella Valley is not significantly different from 150 centimeters, or there is no relationship between living in Coachella Valley and a 12-year-old's height. Those are a couple of different ways that we could say this in what I would consider to be like interpretive language, not just fail to reject the null or reject the null. Similarly, if we were to reject the null, there are a couple of ways that we could say that. We could say the average height of 12-year-olds in Coachella Valley is significantly different than 150 centimeters. It is not 150 centimeters, or it appears that there is a relationship between living in Coachella Valley and the height of being 12 years old. So converting that interpretation, this 5th step, into something that's more of a kind of like a common language version is really important to really show that you know what you did. So in summary, we say what our research question is. We decide the maximum we're willing to be wrong. We run a test and find out what that actual p-value is. We compare our p-value to the maximum chance of being wrong, and then we make a conclusion about our original question. So that summarizes the research testing process. I want to go through a little short example with our Coachella Valley just to make sure that that's super clear. So the null hypothesis would be that the average height is equal, that's HT, is equal to 150 centimeters. The alternative hypothesis, or our research hypothesis, is that the average height is not equal to 150. We would set our alpha at 0.05. We would run our test of significance, and we would calculate whatever. We would come up with probably a t-value, since this is a one-sample t-test. We could calculate that critical ratio, and it would actually give us a number. That t-value is converted to a p-value. And so let me give you 2 scenarios. Either that P-value is a big number. Let's say, let's just give ourselves 0.68. If the p-value is 0.68 and we compare that to this initial number, we would say, ooh, that's a big number. It's too high. So we're going to fail to reject the null. In that particular situation, we say, yep, that looks like a pretty reasonable thing. There's my null hypothesis. That's what I'm testing. It has the equal sign. It looks like the kids in Coachella Valley are not significantly different than what California is. My other scenario is that as I calculate my p-value, I come up with a very small number. Let's say I come up with 0.021. So here's my tiny little number, and I compare that to my original alpha as 0.05. It's smaller. It's less than alpha. My p-value is less than alpha. So in that case, I would reject the null. I would say, no, this can't possibly be true. It's wrong. I must conclude that my average is not equal to 150 centimeters. So that is a summary and an example, and I hope this has been helpful to you in learning all about the hypothesis testing process.